So this video is going to go through an example of solving what we call a quadratic trigonometric equation. So here we want to solve the equation 8 cosine squared theta plus 2 cosine theta minus 3 is equal to 0. And we want to solve this equation for all possible solutions for theta between 0 and 2 pi. Now the first thing we notice here is that this expression on the left-hand side of this equation, where the other side is 0, this looks very much like a quadratic expression. The difference is that we have a cosine theta in place of where we might have just a single variable like x or y. So I'm just going to write down another expression that's similar to this one. 8x squared plus 2x minus 3. So instead of cosine theta, there's an x, and instead of a cosine squared theta, there's an x squared. So if we can factor this quadratic expression, then this quadratic trig expression can also be factored in the same way. So if we look at factoring 8x squared plus 2x minus 3, now you can use any factoring method here that you prefer. I'm going to use decomposition. So I look for two numbers that multiply to 8 times negative 3, which is negative 24. And those same two numbers have to add to 2. So I'm going to use the numbers 6 and negative 4, and I'm going to use those to split up or decompose the middle term of 2x. So 8x squared plus 6x minus 4x minus 3. And then I common factor out of the first two terms. So the common factor there is 2x, and I'm left with 4x plus 3. And there's not really a common factor between these last two terms, but because that first term out of the last two is negative, I'm going to take out a factor of negative 1. And again, I'm left with 4x plus 3. And now the 4x plus 3 is in common. So I take that out as a common factor, and I'm left with the 2x minus 1. So the only difference with this expression and the one that we have in our equation that we're solving is an x instead of a cosine theta. So if I write the factored form of this quadratic trig expression, I can write it as 4, instead of the x, I'm going to write cosine theta plus 3 times 2, instead of the x, I'm going to write cosine theta minus 1. And we can see that if we expand and simplify this, we get the quadratic trig expression in the row above. So this is the factored form of this quadratic trig expression. This will allow us to isolate for cosine theta so that we can eventually solve for what theta is. So at this point, we have two binomials set equal to 0. And so that means that either that first factor of 4 cosine theta plus 3 has to equal 0, or the second factor of 2 cosine theta minus 1 has to equal 0. And we can solve each of these equations separately. So solving the first one, we get 4 cosine theta is equal to negative 3, so subtract 3 from both sides, and then divide both sides by 4 to get cosine theta equals negative 3/4. And the second one, we can rearrange and solve. So add 1 to both sides, we get 2 cosine theta equals 1, and then divide both sides by 2, we get cosine theta equals 1/2. So we at least have cosine theta isolated. We don't have our solutions for theta yet, but we're getting there. Now in this case, we were able to factor this quadratic trig expression on the left-hand side of this equation. And so we were able to isolate for cosine theta by factoring and setting each factor equal to 0. If this quadratic trig expression was not factorable, then we may actually have to solve for cosine theta using quadratic formula in this case. So you can think about how that might look for another question where this expression is not actually factorable. Okay, so I'm just going to move this to the next page so we have some more space. So we're starting here with cosine theta is equal to negative 3/4, and cosine theta is equal to 1/2 was where we left off. Okay, so looking at this first one, cosine theta equals negative 3/4. We know that the cosine ratio is negative in quadrants 2 and 3. So we can draw out our Cartesian plane, and we're going to have solutions to this in quadrant 2 and in quadrant 3, where both would have the same related acute angle beta. I can write the cosine ratio for beta using the positive value of 3 over 4. And the cosine ratio of 3 over 4 does not come from our special triangles. So we're going to use the cosine inverse to solve for beta. And we get that beta is approximately 0.7227 radians. So if we use that on our diagram, we have this is going to be theta 1, so our first possible answer. And this is going to be theta 2, our second possible answer. And so using this value of beta, we have that theta 1 would be pi minus beta, so pi minus 0.7227. So theta 1 is about 2.4189 radians. Okay, that's our first possibility. Our second solution is theta 2, and that comes from pi plus beta, so pi plus 0.7227. And so theta 2 is about 3.8643 radians. Okay, so this first ratio here of cosine theta equals negative 3 over 4 gave us two possible answers for theta that would both solve that initial equation. Next, we go on to the second piece. We have cosine theta equals 1/2. And for that, we know that the cosine ratio is positive in quadrants 1 and 4. So we're going to draw out in our Cartesian plane that we have solutions here in quadrant 1 and quadrant 4, where both would have the same related acute angle. I'm going to call this one beta 2, because this is likely to be a different beta than what we just used in our first set of solutions here. And we're going to label the answer in quadrant 1 as theta 3, because we've already used up theta 1 and theta 2 for this question. And the answer in quadrant 4 is going to be theta 4. Okay, so we can write the cosine ratio for beta is the positive ratio, which is just 1/2. The cosine ratio of 1/2 comes from our special triangles, so that tells us that beta here is pi over 3. And using pi over 3, this should be beta 2, using pi over 3 for beta 2 in our diagram will give us what theta 3 and theta 3 and theta 4 are. So theta 3 is going to be just equal to beta 2, which is pi over 3. So that's our third solution to our initial equation. And theta 4 is going to be 2 pi minus pi over 3, which means that theta 4 is 5 pi over 3. So this quadratic trigonometric equation ended up giving us 4 possible solutions between 0 and 2 pi: theta 1, theta 2, theta 3, and theta 4.